Generally speaking, negotiating and locating the MB2 can be challenging in these upper molar cases. Notice that periapical MB1 and MB2 are generally overlapping, so it's hard to get a really good definitive understanding of the morphology of these canals. CBCT definitely is an advantage, and here you can see where the MB1 and MB2 join, and that just happens to be about at working length 16 millimeters approximately. So I know that my working length on the MB2 is going to be 16 millimeters, and the MB1 will go to full length. At the MB1 MB2 joining point, there's generally quite a sharp transition angle that you don't want to take the file around. So working in the MB2, which is about there, generally is located under that little ledge of dentine that's mesial. So what we want to do is take the ultrasonic tip, here the ultrasonic BL3 tip, and just remove that ledge of dentine to expose that MB2. So here we're just mapping the exact point of entry from the CBCT. Notice the MB2 is generally mesial, or nearly always mesial, to the line between MB1 and palatal. Generally it's about 2 millimeters from the MB1, and from the line between MB1 and palatal it's generally 1 millimeter-ish, but it can be quite variable. Actually the MB2 can be very much more palatally than I've indicated here. Notice the white line between MB1 and MB2, the isthmus, and the white dot where the ultrasonic has forced some dentinal chips into the canal. So quite often we're looking for white dots when we're trying to locate canals like this. Pre-bent Comet patency hand file. The Comet patency hand files are very useful for these kind of calcified canals, simply because they're made of carbon steel and not stainless steel like your normal files. This makes them somewhat more easy to negotiate. It's the very heavily calcified canals. Here the first rotary file that we're using is a size 20. This is following straight behind our patency file, size 2004. We're taking back the patency file, should be working through irrigant here, and then the next file is literally the 2504, taking it a little bit deeper down into the canal. So just literally opening up that coronal extension into that canal. Irrigate, recapitulate, irrigate. So between every rotary file, irrigate, recapitulate with a small hand file, irrigate again. The next file we're using is we're taking down to 16 millimeters on both the MB1 and MB2. So this is the joining point, and that's the 2004 taper, irrigate, recapitulate, irrigate. Notice the recapitulation file, or the patency file that we're using here, the 06, we pre-bend, and as we're watch winding, that really does shake up the irrigation inside the canal. It's a sort of a washing machine action. So we're at 16 millimeters on the MB2 and the MB1. So notice the translocation of the original MB2 position underneath that ledge, which has come now mesial about 1 millimeter. I'm just going to open up the orifices of the MB1 and MB2 a little bit to allow my gutta percha easier entry. And this is an 06, size 15 edge file. Notice too that we're just going to show you in slow motion how this Tri-Auto ZX2, when it hits your torque limit that you preset, starts to reciprocate rather than just kick you out of the canal like most rotary systems do. So that reciprocation, when it hits torque limit, increases your safety margin on any file system you're using by 50%. So that's where we translocate our orifice from the start to the finish. Start to finish literally is about 1 millimeter mesial and 2 millimeters from your MB1. So there's the mapping, and here is the original shape of your pulp chamber, the original shape of your ledge that is in the pulp chamber. And so we have to remove that ledge with the ultrasonic tip. MB1 to MB2, generally 2 millimeters, but it can be quite variable and can extend right across the palate at some stage. And from that line, it's about 1 millimeters mesial. So you can see literally the dentin that we have to remove there. This is the X7 file system that we are using to negotiate and shape these extremely challenging cases. Just notice the exit profile of the MB2 canal is mesial. So that's why we have to mesialize that part of the canal that we just did, the coronal section, to allow free fall of our files into the MB2 system.